More transformation review. Hopefully you've seen the other videos. This is just going to be a review of all those concepts. So for this one, we're going to name the transformation that takes place, going from figure 1 to figure 2. So the arrow was originally in quadrant 1, and now it's in quadrant 3, but it's facing the same direction. This is going to be a translation, a down and left or left then down translation. That's when you're sliding it around. So for this next one, we have the arrow in quadrant 1 originally, and now it's in quadrant 2 and it's pointing upward. It's going to be some kind of rotation. Since it's in a neighboring quadrant, it's going to be a 90-degree rotation counterclockwise. So for this one, we have from quadrant 1 to quadrant 3, and it's going in a different direction. So this is going to be a rotation of 180 degrees, 180 rotation. It's as if you put your finger on the origin and spun it a half circle. As soon as you have an original shape becoming larger, it's going to have to be some kind of dilation where the shape grows. Now we have this next one. We have quadrant 1 to quadrant 2. It's facing in a different direction, but it's not going to be a rotation because this one's pointing right. It's as if you put a mirror on the y-axis. It's a reflection over the y-axis. So that's rotations and reflections have the arrow pointing in a different direction. So now what we're going to do is talk about individual ordered pairs and how they change when you apply these different transformations. For translations, that's when you add or subtract to one or both of the coordinates. You're adding to the x or subtracting from x. Same thing with the y's. You could add or subtract something to it. Next, we have reflections. With the ordered pairs, you're going to take the opposite of one of those ordered pairs coordinates and keep the other. If you're reflecting over x, you keep x, take opposite of y. If you're reflecting over y, you keep y, take opposite of x. Rotations, you have 180-degree rotations. You keep your ordered pair where they are, and you just take both their opposites. For a 90-degree or a 270-degree rotation, you switch the coordinates and then figure out what's positive or negative by what quadrant the new location is. For dilations, you're multiplying both coordinates by a common scale factor. You could also divide by a number as well. So when we have something like this, 5, 4 turning into 4, negative 5, what kind of transformation would this be? They're trading places, so it's going to be a 90-degree counterclockwise rotation. It was in quadrant 1, and then it went to quadrant 2. xy turning into 4x comma 4y. So I don't even have specific numbers here, but I do know I'm multiplying each of those coordinates by 4. That's going to have to be a dilation with a scale factor of 4. Negative 7, 3 turning into 7, negative 3. So I see we're taking the opposite of both coordinates. We left them where they are, but we just took their opposites. That's going to be a 180-degree rotation. Now we have 5, 4 turning into 5, negative 4. The 5 stayed exactly where it is. We took the opposite of the y value. The 4 turned into a negative 4. So when you keep the x, you're reflecting over the x-axis. And then we have xy turning into x negative y. It's going to be the same thing. X stayed exactly as it is. It's a reflection over the x-axis. I kept x, took the opposite of the y. Negative 7, 3 turning into negative 28, 12. Well, if you look carefully, negative 7 times 4 gives you negative 28. 3 times 4 gives you 12. We're multiplying them both by 4. That's going to be a dilation with a scale factor of 4. Now we have this, we have x, y, we have the x's and y's trading places, and we have one of them being turned into a negative. It's going to be a rotation as soon as you see that they trade places. Negative 7, 3 turning into 2, 3. Well, the 3 stayed exactly where it is, and the negative 7 turned into a 2. The only really thing you could be doing here is adding something to the negative 7. You'd be adding a 9 to it to get to that 2. So if you're adding to the x value, you're moving it right 9 places. A horizontal translation of 9, or just right 9. Be aware that right 9 and horizontal translation of 9 mean the same thing. Horizontal dealing with side-to-side coordinates. Alright, xy turning into negative x, negative y. So you just keeping them where they are, taking the opposite of both of them. That's a 180-degree rotation. Negative 7, 3 turning into negative 7, 0. The x value stayed where it was. That didn't change at all. And I'm changing my 3 to nothing. I'm subtracting 3 from it. A change in y, when you're subtracting from the y value, you're moving it down. So I'm subtracting the 3 from the y value. A vertical translation of negative 3, also known as down 3. Once again, fancy words to say down 3. Vertical translation of negative 3. Vertical dealing with the y-axis. xy turning into x, and then y minus 8. So that is subtracting 8 from the y value. You're going down 8. Translation, down 8 units, or vertical translation of negative 8 might be another way you hear it. A lot of fancy ways to say it. That's about it. Hope this helps. Best of luck to you.